Okay, hopefully you can see this, Amanda, but what we're looking at here is the basic kit for the first up science experiment. Got a data logger, and obviously I can't zoom on this, but what we're measuring here is the luminosity, so the amount of lux. We've got our solar kit here. We've got a multimeter, which is going to record either current or voltage being produced by this, and a set of leads. Okay, these will be in the trolley. All the stuff's in the science trolley, isn't it? Just briefly to explain what's going on. If you have batteries like this, okay, a normal set of batteries, you can configure them in different ways, and when you configure them, it produces different amount of energy. For starters, normally, if you're in a torch or something like that, you put the batteries head to tail, positive to negative, like that. That's cool. Here's the positive end, negative there, positive there, negative there. So it goes in a straight line. That is called series. Okay, that's a really inefficient way of actually producing energy, but it produces high current, which means you can get very bright light bulbs. So that's good for torches and things like that. The other way to do it is like this, side by side. When you do them side by side like that, you put a wire positive to positive end, negative to negative end, and you have leads coming off this way. Alright? Much the same as you'd find in a car battery. It's very much the setup in a car battery. So two ways of setting up a circuit. Series like that, nose to tail, or parallel like that. Positive, positive with a lead going out here, negative to negative with a lead going out here. Okay, that's the fundamental setup. This is a solar cell or a photovoltaic cell. Comes with the solar kit, which is going to be on the stand. What we have in mind, I'll turn this around, you produce either a parallel or a series circuit simply by wiring up these leads. These are like three separate batteries, so it's like having three 1.5 volt batteries. One there, one there, one there. And depending on how you configure this wiring system, will produce different amounts of current. And basically that's the entire setup. You can measure that current and the voltage using a multimeter simply by placing the leads on one of these terminals at the back of the system thing here. So you can measure the output by putting it there and there. Or you can measure how much energy is being used by going and attaching these leads to the back of this little motor. It can be a light bulb, it can be a motor. The reason I've chosen the motor is because the motor requires a little bit more grunt to get it going. Obviously in the lighting conditions I'm under at the moment, which is fluorescent lights, we're only producing, according to this, 235 lumens, 235 lux, which is not enough to produce electricity from this thing here. To produce electricity, we need at least 800 lumens. That's another good experiment that I'll go into later, but I mean, you can actually test how much light is required to convert into electricity. The last one, which is probably, remember this is only a 5-minute presentation, the last one is using colour filters. So if I had a torch, I could shine a torch down onto this, and if I had blue light, red light, green light, etc., using colour filters, again you'd produce different amounts of voltage, which would either make this motor spin faster or slower. And pretty much that's it. Alright, it's going to be less than 5 minutes, but there is just so much you can do with this little kit here. As I say, all we're looking at is how much energy we can produce by configuring this thing differently. So, same amount of sunshine coming onto the screen here, and depending on how we wire up the back of this, like that, depending on how we wire it up, that will either spin faster or slower. And we can measure the change using our multimeter. Pretty much, that's it. Okay? Cheers!